now we are going to move to engineering carbon materials. So in the previous lectures, what we have learned, we've learned so many things about the hybridization of carbon, atomic structure of carbon, the classification of carbon, phase diagram of carbon, and many other basic things. Now after that, this was all about, fundamental things about carbon atom, let's say. Now we talk about specific materials, and now I will start with engineering carbon materials. So what are engineering carbon materials? Or they are also known as industrial carbon materials, because they are used in bulk. They are also known as bulk industrial carbon materials. So what are these? Basically, any type of carbon material which is used for bulk or large scale applications. So you may make some structures out of them. Sometimes even you can just process the initial material, raw material, for example, certain petroleum byproducts. They may give you certain type of carbon material. So the refinery, the fact that you obtain the carbon material, the processing that is done, so that is also then it's a part of carbon industry or industrial carbon processing. Okay, now you can use some of these carbon materials for making structures and devices. So what are structures and what's the difference between structure and device? Structure is something that it's just any shape that you give to any material, any specific shapes of specific dimensions, for example. And device is something where you have used multiple structures, and now that particular set of structures now has a function. It is functional. Then it is known as device. So for example, if you have a copper wire is just a structure. But when you make, you use that wire, for example, to complete a circuitry, and then you make a device out of it which can perform certain function, then you now have this set of structures, and which your copper wire now becomes a component of that device. So similarly with carbon, you can make carbon structures, and then those structures can be used for making devices. Now when we talk about these large scale bulk carbons, then for now we are excluding the micro nano carbon materials as well as carbon devices. We'll come to it, but that will form a separate section. Typically micro nano scale carbons are not called bulk industrial carbons, even though some of them may be produced in very large quantities, but they are not used for making large scale structures, and that is why typically they are not called as industrial carbon materials. Okay, so our first industrial carbon material is graphite. It's actually only obvious to start with graphite, because the graphite crystal structure, the properties of graphite, that are fundamental to understanding all other carbon materials. So it's the best idea to start with graphite, and also it is one of the better known materials as compared to the newer carbon materials. So we'll start with that. Okay, now we'll talk about, as I said, carbon-based manufacturing. And carbon-based manufacturing then has two aspects: making the material itself, and then making something out of that material. Structure, device, whatever. You can even take bulk material and then mix it into something. For example, you can take a lot of carbon black and you can mix it into certain rubbers, and then you manufacture tires out of it. Similarly with carbon fibers, you can make composites, and then you can make I don't know, orthopedic implants out of it. So the idea is the carbon based processing happens then in multiple steps. Sometimes you will start with what raw materials you have. From the raw materials you will first do the fundamental processing, and then you will get the purified carbon material itself, and then this carbon material is further processed, and then you make structures, and then you make devices if you need to. So these are all these different aspects of carbon based manufacturing. Okay, now there are many examples of engineering carbon. So graphite, as I said, all of these names, we will talk about all of these things in our lectures in this course. For example, graphite itself, today I'll be talking about the natural graphite. In fact, I'll be talking a little bit about the crystal structure of graphite, but you can also have synthetic graphite. In fact, it's an interesting story about synthetic graphite. In the process of making synthesis graphite, scientists actually ended up making some other interesting carbon materials, and which are also activated carbons, glassy carbons, many other types of carbons that were, the people were trying to make graphite, and it turns out that, oh, this material cannot be converted into graphite. However, the carbon material we get out of it is very interesting. It has its own interesting properties. So you know that this is why also it's important to start from graphite. Now we will also talk about carbon fibers. Of course, we'll also talk about the carbon composites. So carbon resin composites and carbon composites. I've written these as two different types. Carbon resin, as the name suggests, the carbon, you have carbon fibers and you have a polymer. The resins are specific type of polymers, these very thick viscous type of polymers. So you have carbon mixed into a resin, or you have carbon mixed into another carbon material. So carbon is the filler and carbon is also the matrix. So we'll talk about all of these materials. Let's start with graphite. Okay. So as I said, natural graphite is, you know, we'll talk about natural graphite. It is found in nature as a form of a mineral. Where do you find it? You find it in what is known as metamorphic sedimentary rocks. So metamorphic rocks, what are they? So it looks something like this. Okay, metamorphic rock is basically a type of rock which initially had some other structure, but over long periods of time or under very high pressure and temperature condition, its form changed. Now it's a different type of rock. So I'll give you an example. Limestone, for example. If limestone under very high pressure and temperature conditions, it converts into marble. So marble is a metamorphic rock. Similarly, you have a lot of sedimentary rocks. You now, especially in the Himalayan region, you know what sedimentary rocks are. They are formed by the sediments, you know, at some point because, you know, two pieces of land collided and so on. So they are formed by the sediments. But over time, over several thousands of years, their form changes. Also, they experience a lot of pressure and temperature conditions, or sometimes, you know, because of tectonic movements, they also experience sudden pressure and temperature. And because of that, some organic material in these rocks may convert into graphite. So, typically graphite, the natural graphite, is found in the metamorphic rocks. Okay. Now, this can also be formed by what is known as thermal metamorphism. So this is also a type of, so thermal metamorphism is again the transformation because of heat, but in the coal seams. So as you will often find different types of solid carbons also when you have petrochemical refinery, and when you have you know, when you're also when you're mining coal, you will often find some fraction of that coal which has converted into graphite because it experienced a very high temperature at some point. So, or it's also not clear if it was coal and then it converted into graphite, or from the beginning itself the form or the crystal arrangement of the carbon was slightly different. But however, you do find you know, also in coal seams you will find some fraction of graphite. Okay. So basically, if you remember, I have also mentioned this previously, that how are these you know, carbon minerals formed? In most of the cases, you had certain organic material which was buried under the ground, and then over very, very, very long periods of time and several different types of conditions. And also, of course, it also depends on what kind of organic precursor it was, you know, what kind of crystal structure that organic precursor had, what kind of chemical structure it had, whether it was aromatic or whether it was aliphatic. All of these things will make it. We'll learn about all of these things in the you know, future lectures. We'll talk about which polymer will give you which type of carbon, for example. But all of these conditions, ultimately, what has to happen is the non-carbon atoms from your organic material need to cleave and leave. After that, whatever is left is your carbon, and now these carbon materials can be in different forms, graphite being one of them. Okay. So yeah, graphite ores. Now when you you know what is an ore, whatever you, when you just mine something, the first material that you get, that is known as the ore. Okay. Now graphite ores are classified based on two things. More important one is the crystallite size. Typically, you know, the crystal, when you have larger crystallites of graphite or larger crystals of graphite in a certain ore, that obviously has more value, because the larger the crystal dimension, the better you will have the properties, the single crystals. Okay. So basically, based on defects in the size of crystallite, that is number one. That is how you will classify it. The second thing is also based on impurities. Why do we classify some mineral based on impurities? Because those impurities will then determine what processing conditions we need to use. Then, for example, if something has a sulfur-based impurity, then we'll need to clean it in a different way, or silicon-based impurity, then we need to clean it in a different way. So these are the two things based on which the graphite ore is classified. Okay. Now, interestingly, India produces a lot of graphite. About 50 to 20% of world's graphite actually is produced in India and refined in India. Now, especially in the Himalayan region. So we also have in Aravalli Mountains, other places also have graphite mines. But Himalayan graphite has some special properties. The speciality of the Himalayan graphite is the crystallite size. So as I said, this is something that increases the value of your ore, and because of the formation of Himalayas, because you remember that I think I mentioned it before in one of the first lectures, that you had two large tectonic plates colliding, rubbing against each other, which led to extreme pressure and temperature conditions. And those plates probably contained also a lot of organic materials, because after all, one island collided into a bigger chunk of land. So there was also a lot of organic material. And at that time, because of these extreme conditions, you had large crystals of graphite forming. So Himalayan graphite actually is known for that. And not only that, so not only just for technological applications, but also this helps you understand the formation of the Himalayan mountains. So it is also very important for the geologists, and there are many publications on it. So one reference I have given, but you can probably find some more. Okay. Okay, so coming to the large-scale applications of graphite, this picture here, also I had shown you before. You can see that some of the basic applications of, or more, or rather well-known applications of graphite are listed here. So you will use it, especially in batteries and storage devices, energy storage devices. You must have heard that we use graphite. You have graphite in your pencils. You also use graphite in the foundry. You can, and it's also a solid lubricant. So these are some of the very, very basic and very well-known applications of graphite. Okay, so one application that I have not mentioned here, and also because lately this application has not been, it's not so common anymore, but rather in the early nuclear reactors in the 50s and 60s, at that time, graphite was used as a moderator material in the nuclear reactors. What is a moderator material? When you have the nuclear chain reaction inside the nuclear reactor, then what you need is to slow down these neutrons. Actually, there is a certain speed of neutrons that is optimum for the nuclear reaction. So these materials are known as the moderator materials, the materials which would absorb the neutrons, but not completely absorb, they will slow it down. So graphite is used because it's a small atom. Graphite actually serves as a good moderator material, and that was one of the first very large scale applications of graphite. So solid state batteries, that's another one. But a very large scale where you needed hundreds of kilograms of graphite, and also that graphite could not be reused after it was because there was so much so many neutrons were hitting it afterwards, it was not usable anymore. So this was an application which demanded very large quantities of graphite. And this is why, and also not just very large quantities, it also demanded very clean and high purity graphite, because you cannot take too many risks with the nuclear reactor, right? So this is one of the major applications of graphite, which actually led to the synthetic graphite production, which we will talk about later. Okay. Now, so yeah, this is again, I have written the properties of an ideal moderator. It should be a small atom which does not completely capture the neutrons. So, or at least it has a very high efficiency of providing you the neutrons with the right speed that are optimum for your reaction. Okay. Nowadays, however, a lot of nuclear reactors are using water, and there is a reason for it. If you read about the Chernobyl accident in Russia, which took place, If you read about it, I will not discuss that because that is not a part of this course, but if you read about that, there graphite was used as a moderator and the nuclear reactor caught fire, and unfortunately also graphite participated in that fire. So since then graphite or carbons are typically not used for nuclear reactors. However, you'll still find some reactors. More common material for this purpose nowadays is water, also because water is so much cheaper. In fact, the efficiency of water is not that great, but since it's really cheap, practically for free you can use water. That's why nowadays water is used very much. But this is one of the early applications of graphite. And of course, solid state battery. So this image here shows one of the very early solid state batteries. Actually, not much has changed in the case of solid state batteries. The materials have been modified a little bit, the efficiencies have gone high, but in terms of design, not too much has changed in the case of solid state batteries. So you will see that there is a zinc casing which forms the anode, and graphite rod is what makes the cathode. Now you will see that what is filled inside the paste of MnO2 and ammonium chloride, that paste also contains some carbon material. So you can see that carbon was very much important in the case of solid state batteries from the very beginning. Okay. Even today, a lot of batteries now, also with the advent of lithium-ion batteries also utilize carbon, very extensively utilize carbon. So there also we use graphite-like materials or materials with some modified properties, but typically carbon materials are also used. So for battery application, solid state battery. And why do you think for solid state battery carbon is a good material? Because it is, number one, it is mechanically strong. Batteries typically require a material or also thermally strong. Batteries heat up, and now you don't want something that cannot withstand heat. So carbon can withstand heat. Carbon is mechanically strong. Carbon is also very light. So if you make a very large battery, for example, if you use a metal which has a lot of weight, then your battery will become too heavy. But carbon is also light. And of course, it is electrically conductive. Of course, it is electrochemically very stable. These, of course, are the fundamental properties. So because of all these properties, we do use graphite a lot in the case of batteries, solid state batteries. Okay, now the other thing, so I just mentioned that graphite can withstand temperature very well, high temperatures. In fact, if you remember from the phase diagram, what are the properties of graphite? It sublimates. It does not convert into a liquid form. So at 1 atmosphere pressure, it will directly convert into a gaseous form, but that will happen only around 4000 Kelvin, so about 3500 degrees centigrade. So that is, that gives us a good window. Most of our common applications do not go to that high temperature. So for all practical purposes, all manufacturing applications, graphite can withstand a lot of, as compared to other materials, for the cost that it has, it can actually be used for a lot of high temperature elements manufacturing. What are high temperature elements, by the way? So if I have a furnace, what do I do in the furnace? I heat something. Now I want to use that furnace for heating something up to 3000 degrees. Now what is interesting is that how will I make my sample holder? The sample holder also should withstand that temperature, not just once, but it has to withstand that temperature every day, multiple times. So it will also have thermal fatigue over time. It will definitely have here and there thermal shocks. So all kinds of high temperature conditions, the sample holder or all the other elements, all the other parts of that furnace need to withstand. Now these parts, graphite is used for making these kind of parts. So these are called the high temperature elements, not just the laboratory furnace, but also other types of furnaces where you process, for example, other minerals. So all of these are, so whenever you need high temperatures, also sometimes lab crucibles are made of not graphite but graphite-like materials that we will talk about later. So we also use this material in foundry as a refractory material. What is a refractory material? Something that can withstand, that can retain its strength at high temperature. So again, this is the fact that graphite can withstand high temperature is what is used also in the case of this foundry industry. Okay. So for example, if you're doing casting, when you do casting of aluminum, you just want to make certain part, a gear, let's say, anything, if you want to make using aluminum, what you use a sand cast. So sand in that case is a refractory material. But if you want to go to much higher temperatures, and you want to ensure that the thermal expansion is negligible, in that case, for more sophisticated casting applications, you'll use graphite. Okay. Many other applications, actually a few I have listed here, and maybe you can find some more. Steel manufacturing also being one very important industrial application, where you use different types of carbon, and where you not only you use graphite, sometimes you also end up getting some graphite, some graphite precipitates also during the steel manufacturing, and that is so steel, of course, steel manufacturing is an industry very closely related to carbon, because you have carbon in iron, and graphite is very much used for those applications as well.